So hello students, today we'll continue again with unit number 1 and topic number 4, which is types of foundation and its construction methods, part 2. In a previous class we did for part 1 and this is part 2 in continuation. So in continuation with our previous class, our next topic is method of construction of steel grillage foundation. So the first point is, for constructing steel grillage foundation, a trench is excavated to the calculated width and about 0.90 meters to 1.50 meters deep. The bottom of the trench is rammed and leveled. 2. Then a layer of lean cement concrete in the ratio of 1:8:16, which is about 30 centimeter thick, is laid and compacted. 3. After this, a layer of rich cement concrete in the ratio of 1:2:4, about 15 centimeters thick, is spread and compacted to form a concrete bed. 4. Over the concrete bed that is prepared, the bottom tier consisting of a number of steel I-beams of design dimensions are placed at specified distance apart, so using spacer bars. So the space in between and around the steel beams is then filled with cement concrete. 5. On this bottom tier, a second layer of steel of I-beam is placed if required. 6. The entire space is then filled with cement concrete in the ratio of 1:2:4. And then on the grillage bed that is prepared, the structure in the form of a steel stanchion column pier is built. Regarding steel grillage foundation, we have already seen a detailed explanation in our last class itself through the video. So this is just the theory part of it. Next, for timber grillage foundation construction. 1. Wooden planks, usually 5 to 8 cm in thickness, are laid side by side longitudinally on the prepared bed of the trench excavated for this purpose. 2. The planks should be arranged in a width of 45 to 60 cm more on either side than the design width of the base course of the structure. 3. On this bottom layer of planks, rectangular timber sections of suitable size are laid at about 35 cm center to center. 4. Then the top layer of planks, usually 8 to 10 cm in thickness, is arranged side by side with weight equal to that of the base course of the structure that is to be built over it. 5. On the timber platform that is prepared, the structure in the form of a timber column or even a masonry wall is built. Timber grillage foundation also we have seen in our previous class. If you've forgotten it, you can refer to those videos. Next, suitability of steel grillage foundation. Steel grillage foundations are useful for structures like columns, piers, stanchions subjected to heavy concentrated loads and hence are employed for foundations of the buildings such as theatres, factories, towns, halls, etc. So timber grillage foundation is usually provided for timber columns subjected to heavy concentrated loads. So this type of grillage foundation can also be safely used for light buildings where the soil encountered is soft and is permanently waterlogged. The next type of foundation is Raft Foundation. This is common and I am sure many of you have seen it, all of you have seen it. So the foundation consisting of a thick RCC slab covering the whole area of a mat is known as mat foundation. The method of construction of mat or raft foundation. Mat foundation is also known as raft foundation. So number 1, in raft foundation construction, the whole area is dug out to the specified depth and 30 cm more wide than the area to be covered. 2. The bed is compacted and sprinkled over with water. 3. A layer of lime concrete or lean concrete in the ratio of 1:8:16 is laid to a suitable thickness to act as a bottom cover. Number 4. After this, the reinforcement is laid. So the reinforcement consists of closely spaced bars placed at right angles to each other. 5. Then the cement concrete in a ratio 1:2:4 is laid and compacted to the required thickness. 6. The concrete slab so laid is then properly cured. So curing is very important. 7. When loads are excessive, thick concrete beams running under the columns can also be constructed. So suitability of this type of foundation for Raft foundation. This type of foundation is useful for public buildings and office buildings, school buildings, residential quarters, etc., where the ground conditions are very poor and bearing power of the soil is so low that the individual spread footing cannot be provided. So with relation to this Raft foundation, we'll see video after the end of this lecture. Next one, step foundation. Another type of foundation is step foundation. For step foundation construction, excavation is done into steps having short length and uniform thickness, and the machinery work is done on the horizontal bed of concrete that is prepared. So if there is any possibility of slipping of the structure bodily, RCC piles can be driven along its base concrete on the sloping side. Next, inverted arc foundation. So the foundation consisting of inverted arcs between the piers is known as inverted arc foundation. So in this type of foundation, the load from the piers is transferred to the soil by constructing arcs in inverted position. As you can see here in the picture, inverted position at their base. So the rise of the inverted arcs is about 1/5 to 1/10 of the span, and they are usually built in half brick ring. So the position of arcs may be either along the row of piers or across the row of piers in both the directions, depending upon the nature of soil and the type of land to be taken by them. So in this picture you can see the build is in half brick rings. So arcs are built in half brick rings and also in inverted position at the base. So their method of construction is, for constructing this type of foundation, excavation is done to the required depth. The bottom of the excavation is leveled and compacted. Then the foundation concrete is laid to the required thickness and finished according to the layout of the arcs to be constructed under the piers. The arc rings, usually half brick thick, are then built in cement mortar and piers are constructed. The end pier should be designed and constructed to take the outward thrust caused by arc action. Next, suitability. So this type of foundation is not commonly used for buildings, but it is quite suitable for other structures like bridges, reservoirs, tanks, supports for drainage lines, etc. The next topic is deep foundation. The foundation constructed sufficiently below the ground level with some artificial arrangements such as piles, wells, etc. at their base are called deep foundations. So deep foundation is further classified into pile foundation, well foundation and caisson foundation. So here we'll basically study about mainly pile foundation. So what's the pile foundation? It is a spread footing on grillage supported on piles. And a pile foundation usually consists of a base of spread footing or grillage supported by piles at their bottom. So piles distribute the load of structure to the soil in contact either by friction alone or by friction combined with bearing at their ends. We'll understand it more clearly after watching the video. Suitability. So this type of foundation is suitable under the following 4 situations. Number 1, when the soil is very soft and solid base is not available at a reasonable depth to keep the bearing power within safe limits. When the grillage and raft foundation are very expensive. When the building is very high, carrying heavy concentrated load, and when it is necessary to construct a building along the seashore or riverbed. So that's all for this lecture. Well, now you can give your attendance along with your name and enrollment ID in the chat box. We'll also go through 4 videos. Sorry, you'll go through 4 videos if time permits, and if it not, then we'll continue the remaining videos in our next continued class. Okay. So that's all for this class, this lecture. Thank you.
In this video, we will be learning about Raft Foundations, also known as mat foundation. Later in this video, we will talk about reinforcement used in them, so do watch the video till the end to get a better idea about Raft Foundations. Raft foundation is a type of shallow foundation which is a thick reinforced concrete slab spread over a large area of soil. It provides support for several columns and load-bearing walls. This type of foundation is provided when the column loads are heavy or the safe bearing capacity of soil is low. Rafts can have local thickenings or drops below columns. These thickenings are provided if the thickness of the raft is insufficient to bear shear and bending stresses. Rafts can also have beam embedded in them from column to column. These beams can be below, above, or hidden in the raft as per design requirements. These beams provide stiffness to the raft. This type of raft foundation is typically used when column loads are unequally distributed. Raft foundations can be combined with piles when more number of piles are closely spaced and the whole raft acts as a big pile cap. The piles transfer the load to the hard strata below them or via skin friction mechanism in absence of hard strata. Rafts take the load from the column or shear walls and transfer it to the soil below it. The load can be vertical, lateral, or a moment. In return, soil exerts a reaction force on the footing. This reaction and loads from above will generate stresses in the foundation, which will be resisted by concrete and reinforcement. Additionally, reinforcement prevents cracking of concrete due to shrinkage of concrete and temperature stresses. The deflected shape of the raft due to soil pressure looks approximately like the dashed lines. Now let us see the reinforcement distribution in the raft. For simplicity of understanding, we will only look at a part of the raft reinforcement. Starting from the bottom, rafts are provided with a mesh of rebars in both x direction and y direction. Generally, bars in both directions have equal spacing and bar diameter, but may vary as per design and analysis requirements. Additional reinforcement, if required, is provided as a layer above the existing mesh. Usually, additional reinforcement is required below the column as positive bending moments are generated below them. Now let us see top reinforcement in the raft. Similar to the bottom, rafts are provided with a mesh of rebars in top which run along both x direction and y direction. Generally, bars in both directions have equal spacing and bar diameter, but may vary as per design and analysis requirements. Additional reinforcement, if required, is provided as a layer below the existing mesh. Usually, additional top reinforcement is required in the mid-spans as negative bending moments are generated on them. 90-degree hooks are provided at the ends of each rebar for sufficient anchorage with concrete. Shear reinforcement around the column can also be provided if the thickness of the raft is not sufficient to resist the shear. This shear reinforcement can be in the form of shear links or shear studs. They will resist the punching shear and keep the thickness of the raft less. A clear cover has to be left from top, bottom, and sides for the rebars. The value of cover is governed by site conditions and local codes. Cover on the foundations is on a higher side than other members of the structure as they are exposed to soil, chemicals, and water throughout their lifetime. Now let us talk about column reinforcement, which are embedded in the raft. The column longitudinal rebars start with a 90-degree hook in the raft for better anchorage with concrete. They are extended above the footing for sufficient lap length with main column reinforcement. If the above columns are of steel, the lap reinforcement is not needed. Lastly, we see stirrups, which start right from the bottom of the raft. They have a 135-degree hook, which is a must for columns. They tie the column longitudinal reinforcement and resist the shear forces in them. That's it for this video, guys. If you liked this video, give it a thumbs up. Comment below your thoughts, suggestions, or questions regarding this video. More such content will follow, so do subscribe the channel and hit the bell icon to get notified for new videos. Also check.
Welcome to our channel. In this video, we'll discuss pile foundation. What is pile foundation? When do we prefer pile foundation? Types of pile foundation and procedure of installation, and finally conclusion. Let me introduce myself. My name is Vinay, and if you are visiting my channel for the first time video, foundations. We already made a video on what is deep foundation and what is shallow foundation. You can watch the video. I will give a link in the description, also in the I button. You can press here and you can watch the video. They are formed by long, slender, columnar elements typically made from steel or reinforced concrete, or sometimes timber also used. A foundation is described as pile when its depth is more than 3 times of its width or breadth. So here the load is transmitted from superstructure to the ground through these piles. Okay, through these piles the load is transmitted to the ground. Next, when do we prefer pile foundations? When groundwater table is high, we cannot construct shallow foundations, so we prefer pile foundation. Heavy and non-uniform loads from the superstructure are imposed. Also, when types of foundations are costlier or not feasible to construct. When the soil at shallow depth is compressible, when there is possible of scouring due to its location near the riverbed or seashore, etc. When there is a canal or deep drainage system near the structure, we cannot go for shallow foundation, so we prefer pile foundations. While soil excavation is not possible up to a desired depth due to poor soil conditions, then we prefer pile foundation. Based on function or use, they are sheet piles, load bearing piles, end bearing piles, friction piles, soil compactor piles. First, sheet piles. Sheet piles are like barriers and used for supporting from only lateral pressures. In the construction of bridges, these sheet piles are kept and dewatering will be done, then columns are constructed. Next, load bearing piles. And these piles are used for carrying vertical loads from the superstructure. Okay, the load is carried in two ways, mainly through end bearing piles and friction piles. Here, end bearing means the piles are rested on hard strata like rock in the ground. Next, friction piles are inserted up to certain depth and due to frictional forces, loads will be transferred to the ground. Next, when large number of piles have to be used in small area, then soil compactor piles are used. Also, based on materials and construction method, there are timber piles, concrete piles, steel piles, composite piles. Okay, if you want a video on these topics, you can comment below. We'll make a separate video on these topics. Next, procedure of piling. Cast in place piles and precast driven piles. Cast in place means first we have to hammer a thin walled steel tube into the ground. Next, remove all these earth material from the tube. Lower a steel reinforced cage into the tube and cast the pile by pouring wet concrete into the tube. After curing of the concrete, we can remove these steel tube and we can reuse for next piling purpose. Next, precast driven piles. These are cast at the ground level and then hammered or driven into the ground using pile driver. You can see in the picture, this machine holds the pile perfectly vertical, then hammers into the ground with a blow by blow. Okay. Next, conclusions. Whatever the method we use for inserting piles, it should satisfy the basic criteria of bearing the whole load from the structure. Piles are often used because adequate bearing capacity cannot be found at shallow enough depths to support the structural loads. It is important to understand that piles get support from both end bearing and skin friction. We already discussed what is end bearing. End bearing means the piles are supported by the strata of the rock, and skin friction means it is inserted up to certain depth and resisted by the friction of the ground. The proportion of carrying capacity generated by either end bearing or skin friction depends on the soil conditions. Piles can be used to support various different types of structural loads like bridges, skyscrapers, or the buildings which are constructed near the water bodies, etc. Okay, so this is the end of this video. If you are satisfied with our explanation,